your text is back here again. It's been a long while. Welcome back to my channel. I'm really sorry that I had not posted for a while. I was going through some stuff and I was very busy, so I could not really have time to post, but I'm gonna be as consistent as I possibly can from now onwards. So please do subscribe and please do share, leave a comment, give topic suggestions. Everything is welcome. So I'm actually going to be talking about tools to get started with data science. If you're somebody who maybe is from a tech background, or even if you're not. So I'm going to cover everything today. What actually gave me this idea is that a few weeks ago I gave a talk at an expo, and the talk was actually about online tools that you can use to get started with data science, right? It was specifically for health, but I thought that was something that was very important. Actually, I thought it was really cool that let's talk about it. Like, if you want to get into data science, how do you start? What tools do you start with? Because I know it can be very overwhelming when you're trying to learn something, because when you try to learn something and you go online, you're going to see all these tools and all these concepts that you don't even understand. But how do you actually start? What's a better way of doing it? I mean, it's not the only way, of course. You can find your own way that works for you, but I just thought it was really cool for us to really talk about how would you maybe go about it if you want to get into data science. So firstly, I'm going to talk about people that want to get into data science, but maybe you don't have a tech background, so maybe you don't know how to code. So really the advice there would be, you need to learn how to code, because data science, you're going to be coding. You cannot escape. So the first thing that I would say is, let's say that you are from an economics background, or a background that doesn't necessarily have a lot of coding, or maybe you're not that comfortable with your coding. I'd advise that maybe the first start would be to really work on that, right? So maybe learn how to code. If you don't know how to code at all, I think a better way would be to find a good textbook, just so that you get to learn the concepts. But YouTube has awesome tutorials as well. You can really find somebody that you understand, and they can really get you off started nicely, right? They have really great tutorials there. Because you really need to understand the concepts and the thinking that you need to have and all of that stuff. But I'm going to touch, I guess, a lot more on people that maybe know how to program already, or a little bit at least, that at least have some form of programming skill, right? Even if it's a 1, but at least you know what it is, right? So I love HackerRank, and I would always say, if you're trying to learn something rapidly, having a goal makes things a lot easier, right? So you could go on like these platforms where they have these challenges. The reason why I like those is that some of the challenges that you have actually teach you certain concepts, right? And also they also do actually look at performance as well of your code, which is really good, because you want to learn how to make optimal code. You want to learn how to make code that is well written, right? And all of that stuff. So sometimes those things really do teach you the right thinking. How do you need to think about it? How do I optimize my code because it ran for too long and therefore it failed, and things like that. And those are things that are really important for you to think about. But if you now have your programming in order, so remember guys, Python is, I would say, perhaps even the main language that you would use in a data science role, right? Because Python has really great libraries for data science. So I'm just going to touch on that in terms of, let's say that you've got your Python in order now, or if you know other programming languages, it's really going to be easy to learn Python anyways, right? It's really easy Python is really not that difficult. So firstly, data science in general, what is it, or rather, what would your day-to-day be, right? So your day-to-day would consist a lot of analytics. You cannot escape that. But before that, there's the data ingestion part. So there's the part where you collect data, right? Data collection, right? Getting data from multiple sources. You could be getting it from another database, and maybe you want to get it to a data warehouse and all of that stuff. But there's that part where you actually have to have the data, right? Sometimes you might just get like a bunch of CSVs, but sometimes you could be needing to build pipelines and stuff. That is actually data engineering, but depending on where you're going to be working, or whatever role that you're actually going to have, sometimes those things border on each other. You might need to build the pipeline that moves the data from whatever source that it is at to a source that would allow you to be able to actually work with the data, right? So you're going to be doing, I mean, there's a lot of concepts. I mean, things like machine learning, I know that's what a lot of people get really excited about, but that's literally the last part, you know, of whatever it is that you're going to be doing as a data scientist and all of that stuff. It really is a very small portion, but the important thing is collecting data, understanding that data, cleaning the data, you know, feature engineering before you even get to the machine learning part. So the general machine learning process, or I want to say data science process, at least that involves machine learning, would be, as I've mentioned, the data acquisition part. So where you actually acquire your data, right? So as I mentioned, you could be getting it from, you could just get like CSVs or, you know, Excel sheets and all of that stuff with data. But sometimes, and in fact, in a real life situation, you're going to be getting data maybe from another source. So maybe from a SQL database or whatever database, wherever the data is stored, and you might need to move it to somewhere else, maybe to BigQuery if you use GCP and all of that stuff, or wherever, right, where you can be able to access that data for your purposes. Then after you get your data in a real life scenario, so I mean, if you go to just go online and find a data set, sometimes the data might be clean, but in reality data is not clean at all. Like most of the times you're going to get data that needs a lot of cleaning. So this is actually the part where a lot of people would spend a lot of their time, right, where you're actually cleaning the data and all of that stuff. So yeah, you spend quite a lot of time there cleaning the data, understanding the data, making sure that you get the data, making sure that you don't have any outliers that don't make sense of the data. You might need to do a little bit of research of your data as well, if it's maybe a field that you're not particularly familiar with. Let's say that you've got a health data set. In order for you to know if certain types of data have outliers, you would need to know what the data actually means. So here you need to really understand your data, understand the data that you're working with, maybe even ask people that understand the data, you know, what does the data mean? What does it mean when it's a 0? What does it mean when it's 100? Things like that. I mean, you could also have fields that you understand, like age, right? And then you have a 300-year-old somebody, then you know that's an outlier, and you need to make decisions in terms of how am I going to be dealing with outliers in my data set. Do I replace the data? Is it a lot of data that has outliers? Can I afford to drop the data and stuff like that? So now you make decisions. Some of those things you're going to learn as you deal with more data sets, in terms of how do I deal with this for this kind of data set and all of that stuff. And then generally after you've cleaned your data and all of that stuff, you want to go through the data visualization part. So you've cleaned your data, but now you want to really understand now what's happening. What trends are you seeing in your data? You know, what patterns is there? Pattern that you're seeing, is there seasonal? Is it seasonal data? You know, you could be dealing with sales data where you know that maybe we're selling something that people buy a lot in winter. So that's, you could see some seasonality in there where you realize that there's quite a peak in winter, but things go down in summer. So you now need to be understanding your data and visualizing your data. You know, what do the stats say? You know, what's your lower bound and all of those kinds of things. You really need to now really understand your data and everything that's actually happening in your data set, right? And then after that, you go through the feature engineering process, right? So the feature engineering part is really you now saying, yes, I've got all these columns, right? But, you know, are they relevant to what I'm trying to do with the data, right? You know, is it a column that's worth keeping, right? Because sometimes you'd find that you've got a column that's just going to be adding a lot of noise, but it's not necessarily adding any value to whatever purposes that you are trying to actually achieve, right? So that's when you have to now look at things like that. Sometimes you can look at a data set and see what you're trying to achieve and see that it doesn't make sense. But sometimes you use some statistics and all of that stuff to say, you know what, yes, this column adds value to what I'm trying to achieve or not, which is actually the right way to go about it, right? You want to you know, learn some statistics as well. So in order to do this process, you really need to know your stats. We have not even touched machine learning, guys. We have not, right? So you need to now understand your data, understand whether or not a column is going to make a difference to whatever you're trying to achieve or not, right? And then after that, you're going to be choosing features based on the statistics that you're getting, based on also just you understanding what's happening in your data. Sometimes you can make a decision to say this doesn't make sense. Like for instance, if you've got a data set and you've got names, people's names, you can drop names, because the name of a person doesn't really determine anything about them, right? So that's a column that's just going to be adding noise, that's just going to be confusing your algorithm, so you can drop that from the onset. So those are the kinds of decisions that you're going to be making, right? And then after that, with more experience, you will know how to choose the right perhaps the algorithms to start with. You can't really say the right one, because sometimes it's actually all the time it's quite an experimental process, where you say I'm going to use neural nets instead of using linear regression or whatever the case, right? It's sometimes it's quite experimental. You might have to experiment with different models in order to get to a point where you say this model was performing much better, and also to now understand why that model performed much better. But with experience, you'll understand that, okay, because I've got images, maybe these are the models that I need to start with. It doesn't make sense for me to start with this one. But usually that's something that you'll have to learn by reading up on some machine learning stuff. But also sometimes you will maybe try 3-4 models and then see which one is actually performing better and all of that stuff, right? And as you do that, try to make sense of why a certain model performed better than another one, right? And then so then after that, after you've chosen it, there's a process of splitting your data into train, test, and validation. And then after that, you're going to build your model. You're going to be using your data to do that and all of that stuff. You're going to evaluate your model. There's a whole lot of concepts that then go into that process after you've done your machine learning. How do you make your model to perform much better? And then there's the deployment part, where now you want people to be able to use your model, right? This is like just me giving you guys a bit of a summary of what the process looks like. Then there comes the part where you need to deploy your model now, right? So if you have your model sitting in a notebook, it's not usable, because yes, of course, we're going to understand that you've got this great model that predicts this thing really great. But if we can't use it, if we can't integrate it into our platform or our website or whatever the case, then it's not really usable, and it's not really going to be helping anyone. So you need to get to a point where your model is packaged properly enough so that it can actually be used in an application. And that's really the really important part. If you've got this model that can diagnose something, we need it to be able to actually be integrated somewhere where we can then be able to use it. If it's sitting in a notebook, it's useless. So you need to go through the deployment model. Nowadays, I think people use cloud resources, because it's really great, because resources then are not a problem and all of that stuff. But we can cover that some other time. So how do you then now get started? Now that we know what the process looks like and all of that stuff, how do you get started if you're somebody who wants to now get into data science and all of that stuff? How do you get started with that process? I think the first part that I would definitely mention is familiarize yourself with sites such as Kaggle or UCI, where you can get free data sets, right? Because obviously you want to get free data sets. Start with data sets that are simple. Don't go for an image data set. Don't go for an audio data set as a start if you've never dealt with any data, and you know what I'm saying, like, because that's more complex, right? So you want to start with something extremely simple. Go for a data set that has few columns, maybe even few rows. Maybe you want to deal with just a simple data set. Deal with a data set maybe that only has numbers, that doesn't have categorical data. Categorical data is just string data, so like a column maybe with countries and stuff like that. Maybe you want to avoid that, because those kinds of data sets will require some transformation. It will require you to really work with the data to make sure that it's ready for machine learning, right? Because for your machine learning model, you're going to need to be working with numerical data and stuff. So you want to be working with numerical data as a start, because when you have categorical data, there's quite a lot of stuff you might need to do to make sure that your data is actually ready for training, for training and stuff. So look for simple data as a start, and literally now you need to learn data cleaning. How do you clean your data? These are things that I'm also going to cover in the next videos. At the moment, I just want to get you guys started in terms of what the process looks like and what tools. I'm going to talk about what tools you guys should already start learning and all of that stuff. So you want to go through data cleaning, right? Making sure that your data actually makes sense. Do you have any outliers? Does your data make sense based on whatever research you've done, and based on what you know sometimes as well, right? Clean your data, and all of that stuff. What data do you have in a column? If you have numerical data in a column like age, and then suddenly you have string data, is there something you can do? Is it a mistake? Was it also human error? Because sometimes you find that there is human error in a data set, and you need to make decisions in terms of how you deal with that. Then you need to visualize your data, plots, where you deal with your plots, and you're able to say, what, I can see that, there's a peak at the age of 30, or there's a peak at the, when people turn 18, this is how they're behaving based on my data, where you already can tell certain things about you. And by the way, data visualization is very important, because sometimes you can actually make decisions just based on your plots, right? You can be able to say, oh, actually, it looks like in our business, our target market is people between the age of 25 and 35, based on the fact that we've been selling to those people. So these are the people that have been buying our product, and it already tells you a lot, that maybe you need to be, targeting, maybe maybe your adverts are not reaching out more to people of other age groups. So how do we make sure that we bring the other age groups? Or maybe now we actually know who our target market is, and so we need to make sure that we keep on attracting those people. So you can actually make a lot of decisions just based on your plots and all of that. So this is a very important process, and you need to do it right. You need to make sure that your plots actually make sense as well. Then after this, some people would then use stats, just pure stats, without necessarily going to building models and stuff like that. Some people can actually now use stats to just get some insights, to maybe even forecast, and just say, if we use this forecasting method, what does it say about our numbers next year and stuff like that. And those are things that you can do. And sometimes you don't have to do machine learning, by the way. Sometimes just by using some stats and all of that stuff, because stats is very powerful, guys. Machine learning is literally powered by stats. So sometimes by just forecasting, you can really get a lot of detail, right? Like you can get so much, you can actually make decisions, you can tell so much, based on just your stats, your forecasting, and all of that stuff. So just keep that in mind as well. So in terms of now the tools, like what tools do you start if you want to start, to acquire your data? You want to go get your data set from UCI, and you want to clean that data. How do you start with that process? So if you have, you can download Anaconda, right? You can download that. You can get your Jupyter notebooks and be coding there if you like to work locally and stuff. But I would really advise you guys to use Collaboratory. It's a really, really great tool because it's free. And you get a lot of computing power. So you might find that your computer is really not that great. It would be a great one to actually use. You can store your data on, in Google Drive, or wherever. It really does support multiple sources and stuff. So you can store your data somewhere else, which means that your computer won't necessarily be affected much, even if your computer might not be that great. So it's a really great one. And then in terms of actually the data cleaning itself, as I mentioned, Python is a great language to learn when you want to get into data science and stuff. So pandas, you need to know pandas, guys. It is the library that you need to know, right? Associate yourself with that, learn how to use it. Take your time there, take your time. You're going to use it a lot. You're going to use it to clean your data. You're going to use it for a lot of things to make sure that your data is in tabular form, right? It's amazing. Learn it. It's great. You need to learn it, right? So pandas, guys, remember that, pandas. Then in terms of libraries, let's say that you've cleaned your data, you've done all of these stuff, and you want to do just a little bit of some experimentation with machine learning and just maybe see how what's coming out, what are your predictions saying and all of that stuff. sklearn is a great one. Just a few lines of code, you would already have built some model, and it, you can already see how your data is behaving, what your accuracy looks like, which model is actually doing better, because you don't spend a lot of time on it. Really, in a day, you can already have experimented with a couple of models, and you can already say, look, my data performed horribly with linear regression, but it performed great with this other model. So it's a really, really great one. Learn it just for experimentation purposes or even academic purposes as well. But in terms of now, when you are going to go into production, stay away from it because it's not that easy to customize. You would want to learn a library such as TensorFlow or PyTorch and all of those other libraries to make sure that you have more control of what you're trying to actually build. So those ones, when you now want to go into production, that's where you would want to end up, right? So for data visualization, I mean, of course, you can use things like Seaborn, your Matplotlib, to just visualize and plots and all of that stuff. But if you have a data set somewhere and you just want to visualize and maybe just show your data to other people, you've got a data set and you just want to show to whoever and just say, look, these are the things we are getting from the data and stuff. Data Studio is really great. It's free. It can support data from multiple sources as well. So it's a really great one. Like, yeah, learn it as well, guys. It's actually quite amazing. I absolutely love Data Studio. You can visualize, you can have really colorful and beautiful plots with that. So yeah. So guys, I'm gonna end there for today, but I already have a few ideas in terms of what we can talk about next time. I'm still trying to figure out how I can share my screen in case I want to show you guys a few things, you know, that are a little bit more technical. But yeah, we're gonna talk about how, you know, data science. We're gonna learn data science together, guys. We're gonna do this thing together. Thank you very much for watching. Happy learning and happy starting. Please leave a comment, please subscribe, and let me know what topic I should talk about next, right? Like what's more intuitive for you guys. What can we talk about? What can we get into? Please do help me out with that. Thank you guys for watching. Have a great week.